So let's look at another example using the sum and difference identities or sum and difference formulas. So let's look at this example. Use the information below to find sine of alpha plus beta. And really the sine, this could be sine, tangent, cosine, it could be alpha plus beta or alpha minus beta. But you are given enough information right here to find any of those functions. And so what we're going to do is since 4 over 5 and 5 over 12 aren't ratios that are special angles, it's not square root of 3 over 2, square root of 2 over 2, where we know that exact angle that would give us those values. So what we do is we build a triangle for each angle. So let's start with angle alpha. So what we know is that what we're given is that the sine of angle alpha is equal to 4 over 5. And we're also told that that's in quadrant 2. So that's enough information to draw it, right? So we always draw our triangles, right? So the reference angle is being made with the terminal side of the angle and the x-axis. So here's our reference angle. Here's our right angle. And if sine is 4 over 5, then opposite the reference angle is 4 and the hypotenuse is 5. And then we can find the adjacent side by using the Pythagorean theorem. Right, since this is a 3, 4, 5 triangle, that one I know, although we could have just used Pythagorean theorem to find it. So once you have all three sides of that triangle, I can find sine, cosine, tangent, or any of the reciprocal functions of that angle alpha. So what will we need? Since we're finding, the question is actually asking us to find sine of alpha plus beta, what we'll need, so let's use that sum formula, so that's the first one up here, right? We'll need sine alpha, which was given. We'll also need cosine of beta. So we'll have to do the same thing for angle beta. And then to that, we'll add cosine alpha. And then we also will need sine of beta. So again, sine of alpha was given. So I'm going to go ahead and jot down the value for cosine alpha since I'm going to need that too. So cosine is negative. Remember, I also want to think about what's positive where. So cosine is negative in quadrant 2, so it's going to be negative the adjacent side to the hypotenuse, so negative 3 over 5. So I have those two values. So now let's do the same thing for angle beta. So let's see, angle beta is in quadrant 1, so that tells me how to draw that triangle. So we'll draw that triangle like this. So there's that angle that we're talking about. And we're told that tangent beta is 5 over 12. Okay, so that tells me opposite is 5 and adjacent is 12. And again, we can use Pythagorean theorem to find the hypotenuse. So, right, we would say, okay, 12 squared plus 5 squared is equal to the hypotenuse squared. So this is 144 plus 25 is equal to c squared, or 169 is equal to c squared, square root 169, and we get 13. So the hypotenuse is 13. So let's see, what else do we need to know? We also need cosine and sine of angle beta. So let's jot those things down too. So let's see, sine of angle beta is opposite over hypotenuse. So that's 5 over 13. Everything's positive in quadrant 1. So cosine of beta is adjacent over hypotenuse. So that's 12 over 13. So now I have everything I need to plug into the formula. So let's see, sine of alpha is 4/5. Cosine beta is 12 over 13. that one we found over here. Cosine of alpha, let's see, we're adding, is -3/5, and sine of beta is 5/13. Okay, multiply before you add. 12 times 4 is 48, and 13 times 5 is 65. And then to that, we're going to add -3 times 5 is -15, and again, 13 times 5 is 65. So 48 and -15 is 33. That's over 65. So sine of alpha plus beta, the exact value would be 33/65. And again, we could have found, also cosine or tangent, depending on what's asked after we draw the triangles for those angles.